Sticking with the same topology we were using previously, we've got Nexus 1 and Nexus 2. We're going to keep our IP version 6 configuration as well. And we've got a loopback of 1.1.1.1 on Nexus 1 and 2.2.2.2 on Nexus 2. And I have those Nexuses currently open. So we can see here that we've still got reachability to 2.2.2.2/32 using OSPF. So to get rid of that, what I need to do is just do a conf-t and I say no feature OSPF. And we also see that we have reachability to 2:2:2/128 from Nexus 1. So I also need to remove the no feature OSPF version 3. Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the play special. Do you want to know what the play special is? Press like and yeah, subscribe. Okay, back to the video. Yeah, and that's gotten rid of a lot of the commands that we're looking at. So we're going to be moving into ISIS. Now, ISIS is an interior gateway protocol, much like OSPF, and it's a link state routing protocol. Unlike distance vector protocols that learn routing updates from their neighbors, which is called routing by rumor, ISIS uses a link state database that describes the state of the network. And similar to OSPF, it uses the concept of areas, where a level 1 area is a non-backbone area and a level 2 is defined as being a backbone area. Now, IS to IS means intermediate system to intermediate system, and a level 1 intermediate system can only communicate with other level 1 intermediate systems. So to communicate outside of their local area, they must form an adjacency with a level 1 L2 intermediate system. That's how it's going to communicate with level 2 intermediate systems. Now, these devices are level 1, level 2 devices by default. But to properly understand ISIS, you need to get a grasp of the network entity title, which is called the NET. This consists of an AFI, which is an Area Family Identifier. And if you use 49, that is synonymous with being like private addresses. Then you have the area ID, which is 0 to 12 bytes. Then you have the system ID, which is 6 bytes. And then you have the N selector, which is 1 byte. So we're going to get into the configuration of ISIS now. And we're going to start doing that on Nexus 1. And as usual, we have to enable the feature first. So if we say feature ISIS, and then we're going to configure the router tag. And we have the option of numeric and alphanumeric tags here. So if I say router ISIS test 1 again, and then by default, IS types are level 1, level 2. But here, I think what I will do, I will say IS type level 1. And you can see that we've got an option of level 1, level 1, 2, level 2. And we're going to make this one level 1. Then we configure our net address. So we start off with an area family identifier, which is 49, and an area of 0001. Then we're going to configure our system ID, which I'm going to make all ones. I think I will use 111.111.111.111.00. I think that's it. Then we're going to configure the interface E1/1, which is our connection over to Nexus 2, IP router, ISIS, test 1. And what I'm also going to do, I'm going to enable IP version 6. In ISIS, they've got things called TLVs, which are type length value fields, which makes the protocol adaptable. They didn't need to create a brand new protocol like with OSPF because they had the adaptability to add these TLVs or change these TLVs to cater for IP version 6 as well. So we can cater for IP version 6 natively by saying IP version 6 router ISIS test 1. Oh, I've made a mistake there. ISI. Let's get rid of that. I need to have ISIS test 1. And we're going to do the same for the loopback interface. I could just up arrow here. First, we're going to do the IP version 4. No ISIS MTU check level 2 has no effect on loopback 0. Okay, that's interesting. And we're going to do IP version 6. Some ISIS commands may have no effect on loopback 0. Okay, let's see if that works for us. It's taken the configuration, which is what I'm looking for. Let's do a copy run start and then do the configuration on Nexus 2. We're going to see if we've got IP version 6 and IP version 4 reachability. I'm just going to log in here on Nexus 2. Conft feature ISIS, then router ISIS test 1. I've got ISI again. Let me get rid of the ISI. Test 1. I'm going to make this one our level 1, level 2 intermediate system. And now we're having our net address. And because we're communicating with a level 1 intermediate system, the other one was 49. Is it 001? Yeah, okay. 49.0001. And we're going to make our system ID all twos. So 22222.22222. And then have our N selector of 00. And then we're going to configure our interfaces. E1/1. IP router, not IP root, sorry. IP router ISIS test 1 and IP version 6 as well. And then we're going to also configure our loopback and just up arrow a couple of times to take that configuration. Now let's see if we've got reachability, or at least our routes. And we do have our route to IP version 4 route to the loopback for 1.1.1.1. And let's see if we've got our IP version 6 route as well. Yes, it is there. Let's see if we can ping that. So IP version 4 is pinging. And IP version 6 is pinging as well. That's excellent. And to see ISIS neighborships, we say show ISIS adjacency. And we do have an adjacency. And it's a level 1 adjacency. And this is actually the MAC address of Nexus 1. And this SNMPA is called a System Network Point of Attachment. And it uses the MAC address of the neighbor. Show ISIS. Lots of nice information here. Our system ID is all twos. We are a level 1 L2 intermediate system. Our area address is 49.0001, which is our AFI and also our area. We have an administrative distance of 115. Lots of juicy information there. And if you just want to see the configuration that I've done, show run ISIS. And this is the configuration I've done on Nexus 2. And again, if you want to see a lot more of this information on ISIS, like wide metrics, narrow metrics, I'm more on TLVs and L1, L2 communications, then go to www.routercoach.com, jump on one of our boot camps, find the date that you're looking for, and we'd love to see you there. The next stop is BGP. This is going to be kind of a bonus video because I wasn't going to cover BGP. But when you think of it, if you're doing unicast routing, you can't really avoid covering BGP as it is the largest routing protocol out there. Bigger than OSPF, ISIS and EIGRP. Probably bigger than all three of them put together, to be honest. But let's get into it. So this is the topology that I'm going to be using. Now I have 6 routers, Nexus 1, Nexus 2, 3, 4, 5 and 6. For this video, I'm only going to be using Nexus 1 and Nexus 2. And I hate to keep banging the drum, but if you want to see more of the configuration of BGP on the Nexus platform, go across to Router Coach, www.routercoach.com, sign in for one of our boot camps, and we're going to go through everything from 4-byte AS numbers, local preference, route maps, all of the BGP attributes, AS path. There's a whole heap of things that we're going to go through. It's actually going to probably be a few hours just on its own because BGP is such a big topic. But here we go. We're going to look at Nexus 1 and Nexus 2, and I currently have those devices open. So we have Nexus 1 and Nexus 2. If I do something like show run BGP, yeah, BGP isn't currently operational. Now what we have to do to actually, let me just give you an overview of BGP first, give you a bit of the spiel. So BGP stands for Border Gateway Protocol, and it is an exterior gateway protocol, which is the routing protocol of the internet. Now it mostly operates between autonomous systems, although it can actually operate within an AS. I will call an autonomous system an AS. And an AS is a collection of routers under a single organization's control. Now, BGP is often classified as a path vector protocol, where the term path vector in relation to BGP means that BGP routing information includes a series of AS numbers, indicating the path that a route takes through the network. This is done through the BGP AS path attribute as a loop prevention tool, where if a BGP device receives a prefix advertisement with its own autonomous system number listed in the AS path, it discards the prefix because the router thinks that the advertisement forms a loop. Now, internally within an AS, you often have an IGP or sometimes even multiple IGPs, but the autonomous system must appear to autonomous systems that are outside, so external ASs, they must appear the same in regard to routing policy. So it uses an IGP to advertise internal routes, and then the external ASs don't even know that you're using an IGP. And an IGP isn't actually required within an autonomous system. You could just use BGP internally as well. Now let's have a look at this diagram here. And in this example, we see that AS100 and AS300 aren't even aware that AS200 is using OSPF and ISIS as an internal IGP because the routing policy appears the same. So let's have a look at the actual configuration of BGP. The first thing, as always, let me go on to Nexus 1 first. First thing we need to do is show run BGP. We can see that there's nothing there, and we need to enable the BGP feature. So feature BGP. And then I could say router BGP 6500. Now, when you've got 2-byte AS numbers, the biggest number you can go up to is 65535. And I'm going to show you how the Nexus can actually also accommodate 4-byte AS numbers when I do the neighbor command. Now, with BGP on the Nexus, you have to configure the router ID. So I'm going to make the router ID the loopback address. If I just done a show IP interface brief here, you can see that the loopback address is 1.1.1.1, and then I'm going to configure the neighbor. So the neighbor is going to be our directly connected interface, which is 10.1.12.2, and our remote AS. Now I'm going to make the remote AS a 4-byte AS number. Now, as I said previously, the highest number you can do on a 2-byte AS is 65535. If you were to do now with the 4-byte AS number with dotted decimal notation, Say if you wanted to do 65536, which is one up, what the AS would do, it would make it 1.0. So the 1 is 65535 and the 0 is the next number up. So it goes from 0 to 65535. And if you had 65537, it would be 1.1, and 65538 would be 1.2, all the way up. So if I done a number like 65,000.65088, what number would that be? It's going to be like 4 billion and something, isn't it? Because it's got to have gone to 65,000, 1.0, then 2.0, 3.0, 4.0, and it keeps going round each time. But we're going to check what number it is. All right, now to actually activate this, here we have to put under the neighbor, we have to put the address family. Now I'm going to omit it, but we're going to come back to it. And this is going to be like a troubleshooting part. But if you don't put the address family here, your neighbors will not come up. But we're going to omit it to make sure that you see that as an example. And then we'll exit out of this. And then we're going to say for our address family here, now IP version 4, let's do a question mark here. You can see we could have multicast under IP version 4, MVPN and UNICAST. We're going to be using UNICAST. And you could also have the same for IP version 6, look. So you could have it IP version 6. And to be honest with you, BGP is the most flexible. It has support for IP version 4 Unicast, IP version 4 multicast, IP version 6 Unicast, IP version 6 multicast, and VPN version 4. There's a whole heap of them. Look, L2 VPNs, lots of it. But we're going to just stick with IP version 4 Unicast. And we're going to, this is where we're going to advertise our network, which is our loopback of 1.1.1.1/32. It has to have the exact mask on the end. And if I do a show IP BGP, we can see that that network is here. Let's do the same on Nexus 2. So first, feature BGP, router BGP 65,000.65088. Then our neighbor, which is 10.1.12.1 with a remote AS of 65,000. We're going to put the address family here, address family IP version 4 Unicast. Exit out of here and exit again, because if you try to do the network command here, you can't do the network command under the neighbor address family because it has no network command actually available. It has to be under the router address family. So let's say address family IP version 4 Unicast. We're going to advertise our loopback, which is 2.2.2.2/32. Exit. Now, if we say now show IP BGP summary, we can see that it's idle here because we have put the address family on this side underneath the neighbor. But when we go on to Nexus 1 and we say show IP BGP summary, we get some spiel here. BGP summary information for VRF default address family IP version 4 Unicast. And that's basically telling you that you haven't advertised it for the underneath the neighbor for the address family. So let's do that now. For neighbor 10.1.12.2, we're using the address family IP version 4 Unicast. Now if I say show IP BGP summary, we can see that it's idle at the moment, but look at the AS number. This is the actual AS number. What is that? 42 billion, not 42, 4 billion and something. And that corresponds to our neighbor of, no, not here. We're 6,500. That corresponds to our neighbor of 65,000.65088. Let's just make sure that it has come up. Show IP BGP summary. And it has come up. And we can see that now we have one prefix. So if I now say show IP BGP, I can see that this little L here means that our local route is 2.2.2.2, and the E means our external route is 1.1.1.1. Let's see if we can ping that. Ping 1.1.1.1, and it is reachable. All right, as I said, in our bootcamp, we will be looking at things like update source, eBGP multi-hop. We'll go through all of the BGP attributes like wait and local preference, AS path, MED, origin. We'll look at some communities. We'll do some route maps for redistribution, and there's a lot more. But if you are looking for a basic configuration of BGP, that is it on the Nexus platform, and I'll see you in the next video.